About what time did people start taking measurements of temperature and such that are good enough data to use today?
There are incidents of guys like Benjamin Franklin and that writing things down as far back as a couple hundred years ago. But as far as a routine, systematic, since about the middle of the 19th century, around the beginning of the end of the Little Ice Age there. So, and then transmitting them and keeping detailed records. But as far as an organized thing, only for about 150 years. So, and it all had to do with communication. So technology drives a lot of this.
So is that, like, is Ben Franklin's data not really useful to you guys
yeah,
because it's intermittent, or?
Back then, people didn't really understand what was going on, but they would take things. It was interesting during the period of the American Revolution, looking at letters like John and Abigail Adams. There was no theory that in Boston we had a big storm, and you wouldn't get the letter for 3 weeks, and people didn't put together that the storm in Boston might have something to do with the storm in New York. So technology has enabled, the atmospheric sciences especially, and the other geosciences to. And now with satellites going on, I mean, we can see volcanoes erupt when they start. We can track ocean currents, and we've got all this great stuff, and we're learning so much all the time. So now the problem is we got so doggone much data coming in. It's hard to. You can fill up your hard drive real fast. Yeah. Well, let me ask this lady a question.
Did you say what the different colors were?
Well, I did. What these are different patterns reconstructed from different techniques.
Oh, okay. So one of them.
So looking at coral reefs, looking at tree rings, looking at ice
so what it
pockets.
shows is that even though you get different numbers,
yeah. So I mean, this
still
is a way of looking at it. Is look at the difference between that and that. So that's what makes science interesting. Is there's never, nothing ever comes out and slaps you in the face and says that's the answer. I mean, it's really, really hard. It's really hard because you got to go through all this, look at the uncertainties and constantly evaluate this. Science is kind of like peeling back the layers of an onion. And just about the time you think I peel back one more layer, I'm going to get the answer. It turns out, oh, there's a whole other onion in there. Or everything I thought I knew was wrong. That's one of the things I like to tell my students is in the late 1800s, the physicists thought they'd learned everything there was to learn. And they were going around saying, we've learned everything there was to learn. They didn't realize that there was this little Jewish clerk in a Swiss patent office thinking about time and space and light, and the Polish wife of a French chemist who started noticing that if she put her hand between radium and film, she could see her bones. And Madame Curie and Albert Einstein showed us we do nothing. So that's what's great about science. So maybe you kids someday will find out stuff that I couldn't figure out. Yeah.
There's that orange line that starts.
Yeah, see, some of these you can only go back about 500 years. Then the black lines here, that's the modern temperature records like I talked about. So some of these techniques, some of these ice caps aren't that old. You can only go back a little ways. So ones like the Greenland ice cap that have been there a long time, or the Antarctic ice cap. But the interesting thing is we think back to Pangea, Antarctica was actually tropical. So, yeah.
How dependent are we on modern technology in order to record this information? I mean, if the satellites go out of the sky, how?
Well, when I first started forecasting in the Air Force, we didn't have there was satellite data, but only a few people had access to it, and it was classified and all this. But we still muddle through with other. But I mean, the whole development of meteorology has been technology dependent. First with communications, and then we didn't know what was going on in the above the ground until we had radios small enough to hang on balloons to send the data back, and airplanes could go up and stuff. So the technology improvement has given us many more tools to work with. So forecasting severe weather. Of course, when your radar goes out as the tornado is moving at you, which tends to happen, it makes a limit. But now we can just go online and get radar data from anywhere in the world online. Back in, when I was doing it, you could only see the radar you had in front of you. So I mean, it's In the last 40 years, the technology has just exploded. Like I say, now you got so much stuff to look at, it's hard to look at all of it. So that's another thing where robotics come in, is actually the National Weather Service actually has software that looks at the radar data and flags things for the forecasters, because it can look at things a human eye can't see. So you've actually got machines that look at it for you and bring stuff up. So. Well, I see it's almost 2:30, and I think that's the end of our period. Yeah.
Could you recommend a book where we can learn even more about this, that would be kind of at our level?
Oh, well, gosh, that's a good. What I would recommend is, y'all know what Google is?
Yeah.
I would just Google some of this stuff, because you know where all those pictures came from. Just Google it. Some are, if you go to the National Climatic Data Center, there's things. If you go to, let me give you one website, www.ssec.wisc.edu. That's a Space Science and Engineering Center at the University of Wisconsin, and they've got a lot of K through 12 material on meteorological satellites. Yes, ma'am, you have a question?
We were just wondering, when you look at like the yellow line or the blue line, and the changes aren't as dramatic as when you start looking at the black line, which you said is the modern. So how do you know that the warming that we're seeing now is attributed to something, is attributed to the burning fossil fuels and things that humans are doing, and not just something?
That is an excellent question. And one of the techniques that scientists do is regression analysis. And what that is in the old days it was very involved. In the modern days, spreadsheets do it for us. But what they can do is statistically relate one thing to another. So if you can plot this line, and then you can plot CO2 levels and methane levels and all this kind of stuff, and you do a linear regression, and for example, it might tell you that changes in greenhouse gases can account for 75% of the change in that line. In that case, that gives you a pretty good idea that something's going on. Other times, you think you got a great idea, and you find out that when you do the regression against it, it doesn't tell you anything. Now, that's what we call statistical analysis. To really understand it, what you have to do then is go back and say, okay, statistical analysis says that there's a relationship there. But, you know, does the chicken cause the egg or cause the chicken? So then what we typically do is we go back and we build a numeric model on a computer, and we plug the data from the greenhouse gases in and see if that predicts the line. And that's pretty much how it's done in atmospheric sciences. Is first statistical analysis, and then we build a model, and does the model do a reasonable job of predicting? And quite often, you know, it doesn't. We go back to square one and try it again. Yeah? Well, I just did that Wisconsin website. Does it's www.ssec.wisc.edu. And if you go there, there's all sorts of stuff. It's got current images, all sorts of great stuff, and then you type in K to 12, and it's got a whole bunch of resource material. So, anything else? Well, how many of you want to go be scientists now? Well, that's good. You know what they say here at Georgia Tech is that the PhDs in science say, why does this happen? And PhDs in engineering say, how does this happen? Or ask, how does this happen? And PhDs in humanities say, would you like French fries with your order? Okay, well, thank you. You've been a great audience.